This is part two of us building our not so Quicken bank application. And what I want to do now is I want to shift gears for a moment and kind of focus on the building of our classes or models for this application, and then we'll step back in the next set of lectures in building out more details around the UI and what this needs to feel like as an application and navigation, and then ultimately getting the pieces to kind of all fit together. So what I've done is I've created a folder inside of my project called models, and I'm going to right click on that folder and I'm going to add a set of classes. Now, with this being a bank application, what I want to do is I want to actually create a whole series of different types of classes to kind of facilitate what we're actually trying to build. Now, if you think through an application like Quicken or any sort of app that allows you to track and maintain your banking information, there's certain things that you need to take into consideration. First thing that you'll want to probably track is, the actual bank accounts. The next thing we'll want to track is the transactions in that account. We'll want to know the transaction type, and that will be whether it's a deposit or withdrawal. And then if you have a lot of bank accounts, they might be spread across different different banks, so you'll probably want to have something to track the bank itself. So these will be our classes for the application. There may be more, and we may end up unpacking more as we get into unpacking the details around what each one of these classes needs to contain or consist of. But we're just going to kind of start here and we'll see where it takes us. All right, so a bank account is going to have common properties. So we'll probably have things like account number. We'll have maybe like an account nickname. This will just be a name that we can give the account. We'll have an account type, and that may be like checking or savings. So we're going to have those types of properties. Then the transaction for the account, and maybe we'll change this to be more concise, so maybe we'll call this the account transaction. The account transaction will have an amount, so that'll be the amount of the transaction. Transaction type, which we have down here as deposit or withdrawal. A description. We'll want to know what bank account this transaction is linked to. And so we'll track that kind of information. Now, the transaction type itself, we could create that as a class, but within the .NET framework, we have a specialized type that we call an enum. And what an enum allows us to do is it allows us to create types that are not classes, but they're strongly cased kind of value types. So deposit withdrawal, that can be an enum. It doesn't really carry a value itself. It could be treated as a string, but instead of just making it a string that can be manipulated and modified, it's more concrete. It's basically this transaction type can be one of two things: deposit or withdrawal. So using an enum to facilitate that gives us a lot more control, makes it a concrete type. So when we say this account transaction, the transaction type is deposit or withdrawal. So I'm going to go with an enum for this, and you'll see how we do that in our code. The other thing that I wanted to do is up above we have account type as one of our properties. It's kind of the same thing. We have checking or savings. So I'm going to go ahead and instead of saying checking or savings as a string there, I'm going to go ahead and actually create another type down here, which will be account type, and we'll say that's an enum as well. And inside of that, we will go ahead and make it so that this is checking and savings. And then finally, the bank account itself, we'll want to just have some basic information. So we'll have bank name, address, maybe city, state, and zip, phone number, and contact name. So these will be our classes for our application. Now, methods, we may need some methods for a few of these. The one that I'm thinking is going to be the most obvious is with the bank account class. What we'll probably need is a method of current balance. And what this will do is it'll loop through all transaction and calculate the balance. So we'll have a method there. An additional method that we may need is as we're looping through all those transactions, in my mind, I kind of was thinking that the amount would always be, we would always store positive numbers. And that's a banking bookkeeping concept, is that you always track your amounts as positive numbers. You don't actually put negatives, but then you determine whether they're credits or debits. So that transaction type of deposit withdrawal is credit debit. So what we may need to do is have a method here that is the calc value that we can then call to get the positive or negative amount for the transaction. So basically, if the transaction is deposit $50, that's a positive 50 number that calc value would return. If it's a withdrawal of $25, then calc value would return a negative number. So this returns the amount as positive for deposit, negative for withdrawal. Transaction types. So that's just a little bit of brainstorming around what should these classes really look like. All right, so from there, we're going to go ahead and start building these classes. So the first class I'll do is bank account. So we'll create that class. And as I'm going through and coding up this class, I want to talk a little bit around what is the reason for building all of these classes. When you think of a situation where you're writing an application and you think, okay, well, I need to build some classes, what's the reasoning? What's the logic behind building a class? Well, when you're building a class, you're usually building it for the purpose of tracking information or retaining or storing or handling information. So when you think of building a class, think about, why would you declare a variable? Well, you declare a variable to be able to store the information about something. So if you're wanting to create a real simple version of this application, you would say, okay, well, I want to have a variable that has the account balance. So you'd probably declare a double account balance variable. So this is very simplistic. Well, then you also have other pieces of information that you may want to track, like the account name, the type of account. And all of a sudden you'll start thinking, okay, I need to declare all of these different kinds of variables. And in declaring these different variables, I'm going to have to keep track of them and maintain them. Well, that often means that you may want to consider changing your app, instead of just using all of these individually declared variables, moving them into a class. So you can actually organize and group those variables into a unit. And then if you need to create multiple copies of that unit, for example, in this case, multiple bank accounts, then you just create a new bank account variable, and packed inside of it are all of these other smaller variables. So it's very flexible in that sense. And then if you need to add a new variable to track a piece of information about a bank account, all you have to do is add it to the bank account class. And then you have access to that variable, that property, across all of your application. So as I'm working on building out the bank account, I do want to mention to you a concept that's within Visual Studio that's really handy. So what I did here on line 13 is I declared account type, account type. Now, this is the actual variable type, and then this is the name of the variable. Account type as a class, or in our case an enum, it doesn't currently exist. So we can use this accelerator option and we can say generate new type. So Visual Studio is looking at the syntax and the context of what we've typed, and it says, okay, if everything is correct, account type in this particular space should be some sort of a type. It should be a class or a struct or an enum or something. It's the variable type. So it's smart enough to say, okay, well, do you want me to create a class for this, or do you want to generate some other kind of type? So I'm going to go ahead and say generate a new type. This little dialog box allows me to define what kind of type do I want to create and what should its accessibility be. So I'm going to make a public, and you notice here are the kinds that I can choose: a class, a struct, an interface, or an enum. I'm going to say this is an enum, and I'm going to have it stored in the CP Week 5 project, and I'm going to have it called account type. So I click that, the text goes from black to blue, and you'll notice up here I have a new tab called account type.cs. It basically stubs out for me account type enum. Now defining an enum is as simple as putting just a comma-separated list or listing of enum values. So looking at our Word document on the right here, we have checking and savings. So I'll say checking, comma, savings. That is all that we have to do to define this enum. It's as simple as that. Now enums, they can get much more sophisticated, and when we get into the transaction type, I'll talk about being able to do levels of primitive inheritance and what that means to your application as you're defining your enums, and then how those values can interact with other parts of your application later. Alright, so this is our bank account class. Basically within our bank account we have account number, nickname, account type, and then I'm going to also go ahead and stub out our method, which will return a decimal, and it'll be called current balance, and it's not going to take any parameters. And I'm going to throw a new not implemented exception, and that's kind of a reminder to me that if I get down the road of programming this and I forget to program the current balance method, it'll throw an exception and say, hey, this isn't implemented. You need to come back and fill it in. So that's just kind of a reminder for me that at runtime, hey, I forgot to do this. All right, so that's the account balance. So if we right click, add class, and we'll do account transaction. And we'll make this public. And then we'll start putting in our properties. So we'll do a decimal, and we'll call this amount. We'll do another property of transaction type. And we'll also call the variable or the property itself transaction type. Now that's another one of our enums that we need to define, but we'll come back to that in a moment. So we'll do another property of string and call it description. And then we'll have a bank account property. And then we'll have a public decimal called calc value. And what this is going to do is this will return the amount as a positive for deposit, negative for withdrawal. And then we'll throw a new not implemented exception as well. Alright, so that's our account transaction. Now we need to go through and actually set up transaction type. So we'll generate a new type. It'll be an enum public called transaction type. We'll jump into this enum, and we have two transaction types, a deposit and a withdrawal. Now, because the deposits should always be positive and the withdrawals should always be negative, what I want to do is I want to be able to use that information inside of the account transaction calc value. So what I want to do is something to the effect of return amount where the where the transaction type is positive, return a positive. So we could do that a few different ways. We can do a switch statement off of our transaction type. And we can say if the case is transaction type dot deposit, return amount, always positive. Or if the case of the transaction type is a withdraw, return amount times -1. And then we can put a default case and say, if it's not defined one way or the other, then maybe we'll throw a new application exception saying transaction type is undefined. It's not likely that we'll ever get to this point because the transaction type, the enum types, must be defined as one value or the other. And by default, they always go with the first value unless the transaction type inherits from a primitive that is sortable. Sortable primitives are numbers primarily, but you also have chars and a few other basic types that you can inherit from. So this is one implementation. The implementation that I actually want to go with is something a little different, and what I'd like to be able to do is say return amount times transaction type. Now you may be looking at that and going, well, that's not possible because transaction type is deposit withdrawal. The amount is a number. How can we make that work? Well, transaction type, the enum, can actually inherit from int. So we're basically saying that the base of our transaction type is a number. And by doing that, it gives us the ability to do what's called casting of our enum. Now, in order to cast our enum, we have to first define a value for each one of our enums. So we can say deposit equals 1, withdrawal equals -1. Save. Now, by doing that, we now have a whole new level of flexibility with our transaction type. We can now go in, because our transaction type at its core is an int, we can take the transaction type value and cast it to an int. So let's kind of take a step in between what we've written previously and what we're trying to accomplish and look at the possibilities. So we'll go back to our switch statement. And in our switch statement, we're basically saying if the case of the transaction type above, the property, equals deposit, return the amount. Well, we could also say return amount times the integer value of deposit. And then we can say if the transaction type is a withdrawal, return the integer value of withdrawal. So by doing this, we basically are boiling it all down to saying take the amount times 1, which is coming out of transaction type. For the deposit is 1, the withdrawal is -1. So if we take and convert deposit back to the number 1, so it's amount times 1. If it's a withdrawal, it's the amount times -1. And then here's kind of a peek of what transaction type is within context. So deposit is 1, withdrawal is -1. So if that's the actual value coming from transaction type, why not simplify it a layer deeper and then, or a layer further, and simply say take the transaction type, whether it's deposit or withdrawal. We don't really care what it ends up being, but we know that there's a value in there. And if there is a value in there, convert it to an integer, 1 or -1, whatever it is, and multiply it by the amount. By doing that, calc value will end up actually being the positive or negative amount that we need. So this one line of code does the same work as the preceding 10, 20 lines, but we're doing it within one line of code. So there's a lot of efficiency and clarity around doing something as simple as a one-liner to do this type of work. So the last class that we need to create is our bank class. So to do that, we'll do add class to models and we'll call it bank. And the bank class is going to consist of the following. We're going to have a string for name, string for address, string for city, string for state. We'll go ahead and do a string for zip code, just in case we end up moving this application outside of the United States. Zip codes in other countries consist numbers and letters. We'll do a string for phone number, string for contact, and that will do it for the bank class. One other thing that I'm just going to put a note here, and we'll talk about this in the next video, is a collection of bank accounts in this class. So wouldn't it be nice if on this bank class that we could actually see all of the bank accounts in this bank? So how do we facilitate doing that? How do we build collections that are dynamic within another class? So that's something that we'll unpack more in the next lecture. One last thing that I did want to touch on was the account transaction. This was a little short-sighted on my part, is that the amount, we always want it to be positive, but there's nothing here to validate that. So what I'm going to do is I'm going to create a private decimal. I'm going to call it account or amount. And then inside of the property, I'm going to go ahead and make this a get and set and return amount. And then I'm going to say if the value is less than 0, throw new invalid operation exception. And I'll say amount must be greater than, or must be a positive number. Value is, and we'll say what the value is, just so that we have reference. Else, amount equals value. So that way we're just checking to make sure that we're getting good positive amount values being added to our account transactions. And if we're not, then obviously we need to be making accommodations for that and doing some error checking within our property. Okay, so that is the setup for our classes. We now have each one of our classes in place for our application. We still have a little bit of work to do in terms of collections, but we're starting to get to a good point. And then as we continue forward, we'll continue building our Not So Quickin app.